We are discussing about how to assemble a solar hybrid inverter 12 volt 800 VA. For assembling hybrid inverter, we require three main components. First one is the box, a container. Container is required for housing the transformer and hybrid board and wiring inside the cooling fan, etc. is inside the box. The sufficient size is required for housing the transformer size. According to the transformer size, the front of this one display panel is available. Here the display panel is comes. This is on-off switch. On-off switch. Front side this is only. Back side some assembly is already done. Back side one cooling fan portion is available. Here the fan is fixed. Here one connector strip is available. We are assembled here. This first connector strip is for AC supply input and output. Second one is the another connector strip with two connectors. The first one is 4 connectors. First one is phase input phase, input neutral, input earth. This is output phase. Second connector is for solar positive and negative. One fuse unit is provided here for protection. This is the cover. This side vent plugs are cooling vents are available. This both side. We have to provide one net, fiber net is inside the cooling portion because the dust is not penetrated inside the board and transformer portions. This is the cover. Remove the cover. Inside we have assembled the transformer. This is the 800 VA transformer with the 3 windings. The transformer specification is 800 VA 12 volt. The core number for core stack 3 inch. This is the core size is 4 number and stack 3 inch. The winding, first winding 7.5 volt per 12 turn. Wire gauge is 3 into 13 SWG standard wire gauge. Second one is 260 volt per 385 turns, 1 into 21 standard wire gauge. Wire is used. Third one is 14 volt bar 23 turns. The wire gauge is 1 into 26. The first one is 7.5 is winding is this here. This in this. These wires are used. This is heavy one. The gauge is 7.5 volt per 12 turn. 3 wires is used. 3 into 13 SWG. Here we see this is 3 wires. This is this is inside the sleeve. 3 wires. The gauge is 13 SWG. The voltage is 7.5 volt per 12 turns. In the end of the winding wire, we provided legs for frame connection to the board. This is a transformer. 2 windings are separate windings. Here one fan is for cooling fan. The peculiarity of this fan is if the charger portion is on, the fan is starting. If the output load is above 20%, the fan is working. Other time this fan is not working. Here one fuse is provided. I have already connected the AC portions, 4 wires inside. This is 4 wires inside. This is 4 wires inside available. This is for connecting the PCB and the output 230 volt. output 230 volt. This is directly connected to the output point. The neutral point is connected. The fuse is connected through the input point. This wiring diagram is also displayed in this video. From inside I have already fixed the transformer. Display panel is also fixed. The display panel output is this one. This is connected to the main board. This is connected to the main board. 3 switches are provided. This is 15 volt output. This is 230 volt input. This is 7.5 volts per 12 channel. This is connected to the MOSFET provided in the main board. This connection is directly connected to the main board, the FP point. Then we have to use in the main board. This is used here. This is the solar hybrid inverter motherboard. In this motherboard, 4 heatsinks are available. One is the main heatsink. This heatsink is connected by battery 12 volt and solar 12 volt supply is connected to this heatsink. These two heatsinks, these heatsinks transformer primary winding ends are connected, that is 7.5 volt is connected here. Here the MOSFETs are available for 2 MOSFETs in each bank. If we require to increase the capacity of this board, we have to provide 4 more MOSFETs. This is 1 kVA. We have to increase 4 MOSFETs, 2 MOSFETs here and 2 MOSFETs here. This section is called a PWM. Here solar negative is connected, battery negative is here connected. Here solar positive and battery positive is connected. Here transformer primary 2 winding ends are connected here. This is PWM solar charging. The pulse width modulation charging method is used in this board. Here 4 MOSFETs are connected for charge controller. This portion is called charge controller. Here 2 fuses are available. The resistances are these points. The input and output supply are taken here. You have to see the diagram is already. Neutral in is the first point. Fuse output is the second point. Line input is the third point. Line output is the fourth point. This is a 4 points. Here these 4 wires are connected. This is the transformer FB point. Here the 15 volt supply is connected here for battery charger portions. Here 4 jumpers are available. The first jumper is for switch. The main switch is the switch on and off of the inverter. This switch is on, the inverter is on. This switch is off, the inverter is off. This is connected by using wires. Along with the board, the wires are also available. This is a 4 wires, 4 jumpers are available. This is connected to this jumper like this, and connected this side to the main input switch. The switch on, the solar is on. Here 78051 regulator is available. Here 78051 regulator is available. This 7805 supply is given to the display panel. Then this is J4. The 3 jumpers specific functions are available. This one is J4. J4 function is, if J4 is on, the switch is off. These 3 switches are provided in the back side. This one, 3 switches. This is J4. This function of the switch is off. The battery is charging from main supply only. If this switch is on, the battery is charging from solar. If solar current is greater than 3 ampere or more, 3 ampere or more, the J4 switch is on. The battery is charged from solar only. That is a priority is solar. If this is short, the battery is charging from main supply. Next one is J7. This is J7. J7 is for the selection of the battery. If lead acid battery is using with this inverter, the switch is open, lead acid battery can use. If tubular battery is using, the switch is on condition for accurate charging. The next one is J8. J8 function is wide range charging. If any area the EB supply is varying from 100 to 285 range, input supply normally 230 or 220 volt. If the voltage variation is available or the input voltage is very low, from 100 to 285, the switch is off. The charging range is wide range is AC 100 volt to AC 285 volt. If the switch is on, the narrow charging is available. The charging control is 180 volt to 265 volt. That is the J8. J9. J9 is the priority of solar or EB. J9 is open. The priority is solar mains battery preference model. If the J9 is short, on, solar battery mains preference model. The whole descriptions are I have given in the description page. This is J4, J9, J7, J8. This is switch on off switch. Here is the FB. FB is the transformer secondary winding connection. One voltage regulator is available. Charging mode we can be adjusted. This is the main components of the hybrid solar inverter board. This is hybrid. We can connect the solar as well as mains AC supply. If the solar is connected, the solar charging current is more than 3 volt. The EB supply not taken for charging the battery. Otherwise, it will take the charging. The solar hybrid 12 volt 800 VA. The solar panel connection is, I already noted solar negative here, solar positive here. Solar panels capacity. Normally solar panel voltage is 12 volt. Panel voltage output voltage is 18 volt to 22 volt. Maximum 5 ampere. Normally 5 to 7 ampere. We have connected this board maximum 40 ampere solar charging current. Limited to this for MOSFETs, the charging current is limited to 40 ampere. Therefore, we have connected 500 watts panel to this board. Normally connect 500 watts panel. 12 volt 500 watts mono panel or poly panel we can connect. Now we have to assemble this board to this keys. This will take time. This is the main processor IC. This IC is controlling all these functions of this board. The voltage regulation, charge regulation, solar regulation, etc. Everything is controlled by this IC. This is already programmed one. This is the main. This is a relay. This is the main components of the hybrid solar inverter board. This is the back side. This is available in open market. One frame is available at UP. Ajay Electronics. He was sent by requirement. He sent payment. He was sent by post. Nearly 1,900 rupees per board, including cost of transportation. If you have purchased 5 boards, the cost of each board is 1,700 rupees. Only bulk purchase, the rate is less. This is solar hybrid inverter board. Normally, this inverter we have to connect 150 AH battery, lead acid battery, tubular battery we get to connect for this inverter. Then we have to assemble this board inside the case. We already assembled that transformer. We have to even screws, holes, 4 holes are required. This are you using a DC relay for using this one. This is already you have to know. The screws requirement or available. The connecting jacks, the cooling fan, the display panel, everything is available along with the printed circuit board kit. This is known as kit. This kit is used to. So I have purchased this from UP Lalitpur Ajay Electronics and transformer from online from India Mart Thrissur and case from my native place Kottayam, and accessories are already purchased from here. Then we have to require 4 wires. 4 main wires are required. This is 4 wires. These 2 wires, small 2 wires are for connecting the solar panel to this board. This is one side leg, one side screwing for this one. Here screwing inside the board, we have to connect a leg, that is positive and negative 2 wires, and connected battery, another 2 wires. The all wires are of 8 SW 6 gauge. 6 mm core wire are used. This one we have to connect to this one. All connections are provided this board inside. The connections are we have to show in the video. Transformer is placed inside the box. Motherboard, inverter board is placed inside the box. The 4 sides screws are given inside the board, and PCB 1 centimeter gap is available. That is why the motherboard print not touch the board. Now we are give the connections. The transformer primary windings connections are given. These 2 MOSFETs by using these screws. Here one specialty is there. There is no hole for connecting the screws. These screws are placed this slot. This slot and connected this one, and screws are given. That is why this is constructed by the Ajay Electronics. battery positive and solar positive is connected to this heatsink. Solar battery negative is connected to this point, solar negative is connected to this point. This is the main connection, sir. Transformer primary one end is connected to this MOSFET heatsink, second one is connected to this MOSFET. Battery and solar positive terminals are connected to this point, battery negative is connected to this point, solar negative is connected to this point. This is positive, solar positive, this one. These net volts are already in the pitch. Then we have to connect solar negative and battery negative here. Battery negative, solar negative. After that, these 4 wires are connected to this neutral in here. Sign writing is available neutral in fuse wire, line in, line out. These 4 wires are connected. These 4 wires, the gauge of the wire is 1.5 square mm wire. This is used for connecting inside. Other 12 wires are available here. This is a transformer connection. One connection. Other connection is connected to this point and this is connected to this is fuse input point. The fuse input point here. That is why this is connected. Fuse is for the protection. Here one is 2 fuses are available for protection. This is the connections. This is a display. This is a display module. This is connected to here, and it is fixed this board using 4 screws. Battery positive and solar positive are connected to this heatsink. Transformer primary out points are connected to these points. Transformer 15 volt supply is connected to this FB. This one is the FB point. This point is the FB point that is connected. Then this is switch is connected to the switch point. Switch is connected to this switch point. Then display panel connection is going to this stripper connected to J4. To J7. J8. fan. Fan is connected to this point. This one is fan. Our connection is normally over. This is solar negative, solar positive, and battery. Solar positive and negative is connected to this connector. AC supplies are connected to this display, and these 4 points are connected to this LCD supply.